So a stack is a collection that stores in a last in, first out style or order. Um, and stacks and queues are something that you guys need to understand. So a queue is kind of, to me, it's easy, right? It's just like waiting in line, first in, first out. Okay. A stack is quite a bit different. The first people that are in the stack are the last ones that come out. So it's almost like, if you pay for those really expensive seats at a concert and you're like down in the first row and maybe you got let in early, so you're the first one in, you are going to be the last person out of that stadium. So, so you know, uh, the last person in, the ones with the nosebleed seats, are going to be the first people out of there. Okay, so last in, first out. Otherwise, this is fairly similar in concept to a queue. The methods that you are going to use are very similar to JavaScript array processing methods, actually. You will add items to the stack using push. You will remove items using pop. You can take a look at the top item using peek. And you can actually look at the entire stack to see if a specific value is in the stack. And of course, it has clear and count, which all of these collections do. Okay, so the processing in a stack is opposite from a queue. Okay, and let's take a look at our member example, but now our members are in a stack. So we've got Mickey and Minnie. They're going to be the first people in the stack. And then how many members would you like to add? All of these are going to go on top of them. Here, would you like to look for a member? Okay, what's the name of the member? So we can actually check for the value in the stack to see if it's part of the group or not. And then we are counting the members, and then we are displaying them in order. And then here we've got peek that will retrieve our last item in the stack. And we're asking if they want to remove it. And if they answer yes, we are using the pop command. And then we'll take a little peek to see who the next person is and asking if they want to remove them. And we can just stay in this loop and keep popping off people that are on the end of the stack. And then at the end, we're seeing if it's null, which means it's empty. Otherwise, there's still people left. So let us run this. How many members? So I got Mickey and Minnie in there. Do 4. Donald Duck, Daisy Duck, Goofy, Pluto. Would I like to look for a member? Yes. I'm going to look for Minnie Mouse. That member is part of the group. Good. Would I like to look for another member? Yes. Clarabelle. She should not be part of the group. Now I'm going to say no. So these are my 6 members, and you can see Mickey and Minnie were first. And so they are in kind of the reversed order, right? So Pluto was added last, but you can see he's at the top of the list. Would I like to remove Pluto from the end of the stack? Sure. Would I like to remove Goofy? Daisy, no. Okay, so now I have 4 left in the stack. So hopefully this gives you an idea of how the processing is quite a bit different than a queue. So here is another stack example. but this one just has random numbers that I used to populate the stack. Okay, and so I've got integers, and you guys can run this to see how it works, but it is, very similar to the previous example. Well, actually, we can run it. What the heck? Okay, here we go. So we have an integer stack this time that I have populated with random numbers, and the user gets to pick how many numbers they want in the stack. And then we do a for each to take a look at the numbers that are in that stack. How many items would you like to remove? So we're reading that in. And so here you can see that I'm removing items, and we're counting down from that number that they indicated. So if they added 10 items, random numbers to the stack, and I wanted 3 removed, this is going to loop through and pop off 3. And then it's checking to make sure that there's still something in my stack, because if I said I wanted 10 items and then I wanted to remove 10 items, it would be empty. And as long as there's still something in my stack, it's going to display how many items are in it, and it's going to print them out. So we'll go ahead and run it. How many random numbers? Let's do 20. How many do I want to remove? Let's do 15. Now take a look at the numbers because we're dealing with a stack. So, the last numbers in are going to be the first numbers out. 4 was the very first number that was added. 97 was the last one. Yep, probably have to run this again. Got to focus here. We'll try it again. 15. There we go. So here it's showing me each one that's removed and showing me my last 5 numbers. Now these are random, so now I have a whole different list of numbers. So 91 is the last one, 91, 56, 86. Okay, and those are the ones that are still in there. You can see the ones at the top, 96, 5, and 69. Okay, so you can run this and play around with it as much as you want. Just another example of stack processing. Linked list is kind of neat because it's actually implements a doubly linked list. So we've got the value that we're storing, plus it is storing the location of the next value and of the previous value. Okay, and so in order to store those locations, it actually has what's called a wrapper around a linked list node. And the node is the locations that it is storing. So we got a value that we're storing, and we've got locations. And so you can see we've got previous and next. So we got the value 10, the next location, okay, and the previous. Value 20, got the previous location and the next. And you'll notice on either end, we have null values, when the list ends. You can't subscript into this or index into this. It does not support array notation. If you want to add something, you're going to use add first. It puts it at the beginning, add last, add before, or add after. And if you use add before and add after, you have to retrieve the location of that current node. So you will be using a linked list node object. Okay, and then we've got remove first and remove last. Okay, and I did mention linked list node is used to find the next item in the list or the previous item. Okay, so that's basically helping you track where you're at in the list. So here is the syntax. You've got linked lists and whatever the data type is equals new linked list. And you have an initializer that is optional. And here you can see that I've got an empty string linked list. And then I create a little friend array here. And I have another string list. And I took the friend array and used that as an initializer. Okay, and so here are my properties and my methods. And here is a coding example. So I decided to stick with my friend lists. And so I've got my little array here, and I use that as an initializer for my linked list. And I've got a pretty straightforward for each here that is printing out that list of friends. My list object, I can add to the end of the list or to the beginning, which I did. And that's pretty straightforward. Removing from the end and the beginning is also straightforward. You can see it's down here. Very easy to do that. Okay, a little more work if you want to target a specific location in the list, because that requires a linked list node. Okay, and the data type is going to be the same as the data type for your linked list. See, I called it target location, and I'm using the find method to find Donald. And what this is going to retrieve is the location where Donald is at. Okay, and so you can see I've the current friend in the list after Donald, okay, is target location dot next dot value. So the target location dot value is Donald. Target location dot next dot value is the friend after Donald. Okay, and so I'm adding a new friend after Donald. Friend list dot add after. Here's my location. I'm targeting Donald's location, adding in Pete after. Friend list dot add before, targeting Donald's location, adding Huey before Donald. Then I'm displaying that list now with my additions. You can see that I am removing the first person and the last person that are in the list. And then I'm displaying that revised list. Okay, and then I wanted to show you guys how this can easily be converted into an array. So I've got a friend array that I'm creating here, equals new string. And then you just take your list dot count. Okay, and that serves as a size for your friend array. And then there is a copy to method where you can copy each one in your friend list over to your friend array. And once that is done running, okay, then they are equivalent. And here I am printing out the friend array. And I'm finally using clear to get rid of my list, my friend list. So if you want to see this run, so here's my original list. And in my original list, the friend that's after Donald is Pluto. And then if you remember, I added Pete after Donald and Huey before Donald. So here's my list with the additions where I've got Donald, I've got Huey before and Pete after. Then I went ahead and I deleted the first. So I deleted Scrooge. Oh, here I added a couple. We forgot about those. We added Clarabelle and Scrooge. So I delete Scrooge, removing first, removing Clarabelle. Then I print the list without those. And then I convert it over to an array and I print from the array. Okay, and you can play around with this. You can change the value that it finds. And we're moving on to dictionary. Just got a couple collections left. Collection madness. Okay, so a dictionary. Basically, you have key value pairs. They're not in any particular order. And remember, this is kind of similar to a sorted list. In fact, a sorted list can be typecast into a dictionary. So basically, the keys have to be unique. They can't be null. The values can be whatever you want. And if you're familiar with other programming languages, the dictionary is like an associative array. PHP has that, and there's other languages that have that as well. The problem with the dictionary is it can be kind of memory intensive. So just kind of be aware of that. So here I've got the key and the value. So this is going to be a lot like the sorted list. Here we have a key. I wanted to do a little different value. So this is a short integer. And then here I've got the key and I have a float. So I'm just using a couple different data types. You will notice that at the end here, I am giving it a number. That is the maximum number of values that it can have. Okay, so that is an optional entry, but if you do put a number in there, then you are limiting how many items you can have in that list. So here are the properties and the methods that are associated with the dictionary. And by now you should notice that they're starting to look real familiar because we've seen quite a few of these before. And so for this example, I did 3 different dictionary objects: an employee list, a department list, and a salary list. For the salary list, I did limit it to 5, and the other ones I don't have a limit to. So you can see I added some employees, and then I'm printing using the key value. And then I am printing just the value that is stored. Okay, and so one thing I should point out here is that I've got dictionary.keyCollection variable called keys equal employee list.keys. Okay, and then I am iterating through keys. And here I have dictionary.valueCollection values, set that to employee list.values, and I am iterating through that value listing. If I want to just iterate through employee list, then I can actually do a for each on the key value pair, which I believe I showed you on sorted list. And here you can see the data types. This is my alias, key value pair, KVP, in employee list. And so here I am printing out the key and the value. Now, if I wanted to only print out values, could I do that? Sure. I could just omit this. And if I only wanted to print out keys, could I do that? Yep, I could omit that part. Okay, so just because it's retrieving the key value pair doesn't mean you have to print both. So here I am changing some values. Okay, so you can see how easy it is. I am using the key to index in, and I am changing their title. And here I am using the remove method to actually remove an employee. And then I am again accessing the key value pair so you can see that it changed. Okay. And then I'm taking a look at my department list. So I'm adding to the department list. And then I'm going to allow the user to enter some departments. So because I have departments that are already there, I've got enter the name of the department you wish to add, reading it in, and the department name is the key, okay? So if they want to add a department that is already in my list, what I'm doing is I'm removing it, okay? And then I'm having them enter the department number, and I'm just creating a new entry. Okay, and then I'm asking them if they want to do another one. Okay, and as long as they answer Y for yes, we'll stay in the loop. But this is handling, if this is handling duplicates, right? They can't have two of the same key. So if they want to enter IT again, well, we're going to delete the IT that's there and put in a new one. Okay, and so then here, this is counting how many departments are in the list. And we've got a little for each loop that's going to do the key value pair. And then finally, we've got our salary dictionary, where we've got our different positions and the salaries. And this one, I am doing the key value pair as well, but I also included formatted output. So you could see another example with that. So let us take a look at this program. And we will run it. Okay, so here are my employee keys and the values that are associated with those keys. And then here are the keys and the values together. And then I made changes. I removed an employee and I changed some of the values. And then we get into the departments. And I have some departments entered already. And now I'm letting the user enter them. So enter the name of the department. Let's do IT so we can see it get removed. Enter the department number. Let's do 20. Add another. Yes. The department. Let's do marketing. And let's make that department 50. No. All right. So here, IT was, when I initially added it, you can see it was department 2. But when we print it, it's department 20 because it was deleted because that key was duplicate. And then it went ahead and added marketing. And then for the salaries, you can see how nice that formatted output looks. This is our last collection that we are going to talk about. Yay. So the HashSet is an unordered collection, and it is used to implement data sets that are stored in a hash table. And all that is it's a data structure that uses an associative array or a dictionary. Okay, so we just talked about dictionaries not so long ago, and so a hash table implements that. Okay, it maps keys to values. That's all it does. You can use it when you want to prevent duplicate elements, and it does have better performance. Okay, so obviously the elements have to be unique. You cannot sort a hash list. A lot of times it's used to compare lists or combine lists. And so it does have a dynamic size. And this is how you create it. kind of the same as the other collections. And I do have some examples. There are some math operations you can use with a hash set. Union, which combines. Intersect, it looks for the data that's common to multiple lists. And except, this is very similar to what we did in database in the 178 class. Except, basically you have an initial list and except subtracts the items in the exception list from the initial list. So it removes items. As far as properties, you've got count and then the methods. I mean, it's the clear method, the add method, all the methods that you are pretty used to using with some additional ones because we have intersect with, and then we're looking for subsets because it's comparing multiple sets of data. So it's seeing if, one set of data is a subset of another, or if the data is equal to another. Union with, you're combining the data. So I thought it would be helpful for you guys to see some programming examples. And so here we have languages. And so I've got some programming languages, and then I've got some older languages, and I got some web languages. And I did purposefully have a couple that are duplicated. Did that on purpose. And then what we're going to do is combine languages and older languages. So how do we do that? We take the languages object, and it calls .union with, okay, which is a method, and then we're passing it the older languages. And what it does is it adds those older languages into languages. Okay, and then we're writing out the new contents of languages. Okay, and so now languages has all of these. Okay, and so what we're going to do next is we create a little hash set that I'm calling both lists. And I take languages, which is the combined list, and I put it into both lists. And then I use both lists to call intersect with. Okay, and we're passing it web languages. So it's going to change both lists. And it's only going to be displaying the languages that are in both lists and web languages. So where they intersect, that's all that's going to be in both lists. And then we write it out. So let's run this. And I can see it got rid of my string. Hold on a second. All right, had to put that string back in there, and now it's here, so it should run just fine. All right, combined list of older and newer languages. It took this initial list and combined it with this one, so you can see. Okay, and then that's what union with did. Okay, and so now languages is permanently changed. Okay, and so then when I came down here and I wanted intersection, I did not want languages to be changed. So I created a new hash set called both lists, and I set that equal to languages. And then I used both lists to call intersect with. And it looked at web languages, and it only pulled out the ones that were in both lists, which are .NET and PHP. Okay, and that's what it's displaying.